The Appformer framework is a novel mobile application prediction framework that leverages progressive multimodal data fusion and feature extraction. Inspired by transformer-like architectures, it combines a multimodal data progressive fusion module with a sophisticated feature extraction module to process sequential data through self-attention mechanisms. The framework employs points of interest (POI) associated with base stations, optimizing them through comprehensive comparative experiments to identify the most effective clustering method. The refined inputs are seamlessly integrated into the initial phases of cross-modal data fusion, where temporal units are encoded via word embeddings and subsequently merged in later stages. The feature extraction module, employing transformer-like architectures specialized for time series analysis, adeptly distills comprehensive features. It meticulously fine-tunes the outputs from the fusion module, facilitating the extraction of high-caliber, multimodal features, thus guaranteeing a robust and efficient extraction process. Extensive experimental validation confirms Appformer's effectiveness, attaining state-of-the-art SOTA metrics in mobile app usage prediction, thereby signifying a notable progression in this field. The research addresses three pivotal challenges in mobile app prediction: accurately representing core data, efficiently integrating multimodal data, and enhancing feature extraction. To address these challenges, the Appformer framework introduces innovative solutions aimed at enhancing the prediction efficiency for mobile application usage. The key contributions include the Appformer framework, multimodal data progressive fusion, and enhanced pre-processing of location and time data. The authors introduce a novel framework for predicting application usage, addressing the limitations of existing methods. They identified three primary shortcomings: inadequate representation of core data, oversimplified or overly complex data fusion strategies, and limited feature extraction capabilities. To overcome these limitations, the authors propose a new system that leverages rich, interconnected data to enhance predictive accuracy. The problem definition and dataset are presented, featuring a real-world application usage dataset collected from Shanghai, China, during a week-long period in 2016. The dataset consists of various feature data types, including application sequence, user IDs, timestamp sequence, base station IDs, and points of interest (POI) data. The goal is to develop a predictive model capable of precisely predicting the next application a user is likely to use. The mathematical representation of the predictive model is illustrated by equation 1, where a, n plus 1, represents the next application to be used, and x, nm plus 1, n, denotes a multidimensional feature sequence incorporating essential historical data required for prediction. The configuration of this sequence is defined in equation 2, which seamlessly integrates app IDs, user IDs, timestamps, base station IDs, and POI vectors. The data preprocessing for app usage prediction is depicted in Figure 2, involving the implementation of word embeddings, clustering techniques for POI data, and encoding of temporal data. The authors employ word embedding techniques to transform the discrete app sequence into a continuous vector space, utilizing the NN embedding algorithm in the PyTorch framework. The specific embedding process is represented by equations 3 and 4, where the embedding matrix is initialized and updated during the training process via backpropagation. The authors then introduce the Appformer framework, which consists of two primary components: the multimodal data progressive fusion module and the feature extraction module. The framework is designed to effectively leverage the rich, interconnected data, enhancing predictive accuracy for upcoming application usage. Here is a combined summary of pages 58 of the research paper. The Appformer framework is a novel approach to predicting mobile app usage sequences, leveraging multimodal data fusion and a comprehensive framework. The framework consists of two core components: the multimodal data progressive fusion module and the feature extraction module. The fusion module progressively integrates data from diverse sources, including app, user, POI, and time vectors, using cross-modal attention mechanisms and progressive fusion strategies. This module prepares the data for the feature extraction module's encoder and decoder. The feature extraction module, inspired by the transformer architecture, extracts relevant features from the fused data. The encoder processes the fused data, incorporating location and temporal information, and outputs a sequence of vectors. The decoder, utilizing the output from the encoder, predicts the next app usage sequence. The module employs an encoder-decoder architecture, incorporating multi-head self-attention and feed-forward networks to capture dependencies within the data. The proposed Appformer model addresses limitations in existing data fusion and feature extraction methods for mobile app prediction. The model's novel fusion strategies and attention mechanisms enable it to capture complex relationships within the data, adapt to new data types or evolving tasks, and improve predictive performance. The comparative experiments demonstrate the effectiveness of the Appformer framework in predicting app usage sequences, outperforming existing methods. The preprocessing of data involves word embedding for app sequences, user IDs, and time data, and K-modes clustering for POA. The paper highlights the importance of context relevance, delineates the importance of data modalities, and adopts cross-modal attention mechanisms to prioritize important features while reducing noise. Overall, the Appformer framework offers a comprehensive approach to predicting app usage sequences, leveraging multimodal data and novel fusion strategies to enhance predictive performance. The cross-modal data fusion module algorithm is presented, which fuses encoded app vector, A, and POI vector, L, through a series of operations involving masked multi-head self-attention, cross-modal attention, feed-forward network, and layer normalization. This fusion is crucial for obtaining a richer and more comprehensive feature vector. The feature extraction module's modularity allows for easy swapping of its components with those from other well-known architectures, demonstrating adaptability and paving the way for future enhancements. The evaluation metrics used include HIT at K, MRR at K, NDCG at K, and F1 score with a macro setting, with baselines including traditional machine learning classifiers and various deep learning models. The experimental setup involves model parameter settings, dataset cleaning, and partitioning, with a sequence length of 4, embedding dimensions of 16, 64, and 12, and a framework configuration of 128, 8, 0.05, and 512. The proposed method achieves superior performance across various metrics, including hit rate, MRR, and F1 score, attributed to the effective handling and integration of time information, spatial context, and user identifiers, as well as advancements in feature extraction techniques. Ablation studies reveal that time encoding and fusion methods, along with POI data clustering, play significant roles in enhancing the model's effectiveness. Comparative experiments demonstrate the proposed method's ability to accurately capture the inherent patterns of time information, and an ablation experiment shows that feeding only POI data into the decoder yields optimal results. Feature extraction module comparison experiments and clustering experiments with different cluster sizes are also conducted, with the results suggesting that the proposed method achieves the best performance when using 30 clustering centers. The research paper discusses the evaluation of clustering methods for POI data, focusing on determining the optimal number of clusters and testing different clustering algorithms. The authors used various visualization tools and experimental results to demonstrate the effectiveness of the K-modes algorithm in handling noise and maintaining data centrality. The K-modes algorithm outperforms other methods in terms of hit at 1, MRR, and F1 score, indicating its suitability for the task. The study also highlights the limitations of the current approach, including challenges in data fusion, feature extraction, and model updates. The authors suggest directions for future research to improve the model's adaptability and performance. Additionally, the paper discusses the role of utilitarian and hedonic aspects in the continuance intention to use social mobile apps, and how app popularity prediction can be achieved by incorporating time-varying hierarchical interactions. It also highlights the importance of understanding and prediction of mobile application usage for smartphones, and how this can be achieved through various machine learning techniques such as collaborative filtering, deep learning, and multi-view learning. The authors provide a comprehensive review of various machine learning techniques used for app usage prediction, including supervised and unsupervised learning methods, and discuss the importance of considering multiple views of data in such predictions. They also discuss the role of word embedding techniques for text classification and how they can be used in app usage prediction. The paper also reviews various deep learning models used for app usage prediction, including models based on convolutional neural networks, recurrent neural networks, and transformers. It highlights the importance of considering the temporal and spatial aspects of app usage data and how these can be effectively modeled using deep learning techniques. Furthermore, the authors discuss the role of reinforcement learning in app usage prediction and how it can be used to model the dynamic nature of app usage. They also provide a comprehensive review of various evaluation metrics used for assessing the performance of app usage prediction models and discuss the importance of considering both accuracy and interpretability in such evaluations. Overall, the paper provides a comprehensive overview of the state-of-the-art in app usage prediction, highlighting the importance of considering multiple views of data, leveraging deep learning techniques, and evaluating model performance using appropriate metrics.